Hi, my name is Victor Limwanich, and I'm a student here at Central Washington University as a mechanical engineering and technologies major. And I'm working on a Ducati carbon fiber recycler, specifically the conveyance portion of the recycler. And to start off with my project, to give a little background, previously it was mainly it was just a conveyor belt, and this year I was trying to improve it to make a more sturdy conveyor belt while also being able to batch carbon fiber so that there wasn't so much involvement from outside sources such as just waiting at the end of the conveyor belt. My system would be able to batch it onto a plate by itself to be ready to go into the oven next. And to start off, I'll go into my requirements and my analyses. So in fall quarter, starting off with design, I set up a set of requirements, and these requirements varied from different things such as a weight requirement, a footprint requirement, speed requirements such as the conveyor belt going for at least 1 foot per minute, as that's what the shredder goes at bare minimum, and load requirements for my rollers and for my conveyor belt. And for my analyses, I believe these analyses that I'm about to talk about are my analyses which helped me the most in being successful on this project. Starting off, the first analyses would be my belt length analyses, which was pretty much just a very simple analysis which took a distance between roller to roller while also calculating the distance around each roller to get a full linear length of how much belt I would need to create a conveyor belt to fit within my footprint. And this came out to 54 inches or around 4.5 feet. And I was able to purchase a much longer conveyor belt actually, and I just cut it down to size and clipped it down myself. My next analysis is a motor requirement analysis. This was because last year we actually had a working motor, but this motor had plastic gears, so after a certain amount of use, it actually broke down and didn't work anymore. So I was trying to find a good motor which would be able to power my conveyor belt, but also be able to have working gears which would be able to work for years to come. And my next analysis is a bearing design life analysis for the bearings that would be holding my rollers in place, because it would be, these rollers would experience a lot of force due to my tensioning system, which would stretch the rollers apart, and it would also have to be able to run for years to come as well. I came out to a life cycle of 3.6 million revolutions and a dynamic load rating of 17 pounds. And next, I'll go into construction. So winter quarter was the manufacturing process after design in fall quarter. And as you can see here, I have a lot of different systems set into place of assemblies or sub-assemblies that would come up to make my full assembly of this carbon fiber recycler. And there were a lot of changes as time went on. I kind of understood that your first design is not your best design ever. I wanted to do a lot of different things such as folding sheet metal, wanted to do welding, and after some design changes, I kind of understood that a lot of those things weren't entirely feasible, so I made changes such as changing my frame here to aluminum rather than steel. I just pre-purchased pre-cut material for the U-channel, and I use a CNC machine to drill everything out, make sure it was very even, very, very precise. And a lot of the other things I ended up using were 3D printers, milling, drilling, and just doing it all by hand. A lot of these parts were pretty simple, so they were pretty easy to make. The only issues with them were that they were precise enough at their sizes that a lot of them were time consuming. Thankfully, thanks to 3D printing, I didn't have to worry about some of the parts, so I was able to reallocate a lot of my time to doing other things, such as making sure that the CNC worked on my U-channel, which overall that probably took around 8 hours to finish the U-channels, and some other parts such as smaller blocks taking 2 to 3 hours on the milling machines by themselves. And to finish off manufacturing, I had to purchase my motor, and I actually had to wire it up to a proprietary connection at the back of the room here in 127. And it did take a lot of time. I had to understand how the different wires worked, where they went, and what powered what in my motor and from the connection itself. And this did take quite a bit of time, but it was very fun. I do have a finished video of it wired up and working right here. I'm very proud of this because it was probably the most fun part of the project for me by far. And next I'll go into testing. So testing took place in spring quarter. I tested a lot of my requirements to ensure that it was a successful project and it was able to be integrated within my system. So to start off, I did do testing such as a speed test. Like I said in the beginning, I wanted to make sure that it went at least 1 foot per minute. And to do this, I did a speed test right here where you can see that I marked the middle of my frame, and then I also used the alligator belt lacing right here to measure or to time the time that it would take to go 1 full rotation around and come back. And I also did another test, which was my conveyance test, which was just having my carbon fiber come from the shredder and into the hopper and seeing how much of it would be able to get conveyed to the very end. And as for my results for these tests, the speed test was an astounding success. I was able to reach a minimum speed of 4.72 feet per minute and a max of 5.19 feet per minute. But I unfortunately failed the conveyance test as it was between 45 to 65%, where I kind of wanted around at least 90%. But this was due to some of the larger pieces getting caught in the hopper, and a fix for this could be adjusting the rollers a little bit in the hopper, or maybe as a future iteration of the shredder being able to shred the carbon fiber a little more finely. And to finish off with my schedule and my budget. So as you can see here, we use a Gantt chart this year for our scheduling. We have all the different things from design to manufacturing to testing, and everything pretty much went along on time, aside for maybe some smaller issues where I had to order parts and they were either late or they didn't get ordered in time. But I was able to go around this by just starting to work on other things, such as finishing up or redesigning parts to be maybe 3D printed or to be done at the school here in the machine shops. So in this case, I was able to overcome any issues that came about with scheduling, especially with testing. Testing was quite simple. I was able to have a lot of free time here in 127 to test my entire project. And as I was the only person working on it, I didn't have any scheduling issues with anyone else or with having to have others ready for me and waiting for me. And for my budget, I had a total budget of $5,000, and typically this is split between everyone working on the Ducati carbon fiber recycler. But as I was the only one working on it this year, I'm actually able to take advantage of a extended budget compared to previous years. But overall, throughout the entire project, I only used around $1,900, and that's about 37% of the total budget. And if I was able to take into labor, which I'm not getting paid as a student here, this is my senior project that I decided to work on and I chose to work on, it would have been around $4,400. So as a total cost of $6,478, I was able to come under budget, excluding labor, and have a successful project. If anyone has any questions,